Hey, what's up YouTube? Today we're going to be talking about graphing derivatives. So, first I'm just going to draw a regular graph over here. And this graph will just be, that line is way off. This graph will just be an x cubed graph. So an x cubed graph looks something like this. So this is fx is equal to x cubed. And from there, we're going to be talking about how we determine the graph of the first derivative and the graph of the second derivative. So as we know, just by taking derivatives, the graph of the first derivative will just be 3x squared, and the graph of the second derivative will be 6x. But we're going to just, instead of finding it this way and then graphing the derivative like that, we're going to be looking at the max and mins, the relative maximum and minimums, as well as the concavity. So before we get into that, I'm going to be drawing a table over here. And first, we're going to be looking at if the first derivative is, or not the first derivative, the original function over here is increasing or decreasing. So increasing and decreasing. If it's increasing, then that means that the slope is going to be positive. So it's increasing like that, the slope is going to be positive. So the first derivative will be positive. Then if it's decreasing, which we don't see over here, then it'll be negative. So if it was decreasing like that, then obviously the slope would be negative, and then the derivative would have a negative function over here. Now, for the second derivative, this concerns more of the concavity. So concave up, concave down. So I'm going to do con up, con down to show concave up and concave down. Now just a review of what that means. Concave up looks like this. Concave down looks like this. So as you can see, this does change concavity. Over here it's concave down, right? If I continue drawing it like that, it could be concave down. Over here it's concave up, like that. Another way of thinking about it is it increasing at a decreasing or an increasing rate? Because if it's increasing at a decreasing rate, it's concave down. If it's increasing at an increasing rate, it's concave up. So over here, concave up would be positive, concave down would be negative. For the first derivative, this would tell us whether it's increasing or decreasing. So if it's like this, like so. So as you can see, the second derivative is just the derivative of the first derivative, so it's just this again over here. So let's graph the first derivative. Over here, it's going to be increasing, so it's going to be positive, but it's going to be concave, this is concave, down, so it'll be decreasing on the first derivative, so decreasing and positive, so it'll look like that. Then it'll hit this 0 point over here, where it becomes positive and increasing because it's concave up, so it'll look like that. What we have is 3x squared, a parabola. And now there are two ways of graphing this second derivative. We could just use the first derivative, and as we can see, it's decreasing, so it's going to be negative. And then over here, it's increasing, so it's going to be positive. You could also do the same thing here. It's concave down, so it's negative, concave up, so it's positive. And this would be the first derivative, and this would be the second derivative. Now, a few pieces of terminology that would be useful to know. On an interval, so let's say this is the interval, there's always an absolute maximum and an absolute minimum. So this would be the absolute maximum, this will be the absolute minimum. If I had a graph over here like this, where it's like this and this, like this and this, the absolute maximum would be over here, but the absolute minimum would be over here. So it always achieves an absolute maximum. However, there's also something called a relative maximum. A relative maximum is when it changes from increasing to decreasing or decreasing to increasing. For example, a maximum would go increasing to decreasing, a minimum would go decreasing to increasing. Over here, there is no relative maximum because it continues to increase throughout the entire interval. Over here, it does achieve a relative minimum because it goes from negative to positive. And when it achieves a relative minimum or a maximum, or if it's undefined, we call that a critical point. And a critical point will be represented in the derivative as crossing the 0 point, going from negative to positive if it's decreasing to increasing, or the other way around if it's increasing to decreasing. And then the last terminology that you need to know is called an inflection point. An inflection point is when it changes from concave up to concave down, or concave down to concave up, as you can see here. And this would be the inflection point, where it changes concavity, and that's represented in the second derivative as negative to positive or positive to negative. I hope you enjoyed this video. Please give it a thumbs up and subscribe, and I'll see you tomorrow.